Hello. In this lesson we begin Chapter 6, Addition. In fact, the next 4 lessons we will talk about addition. Today we'll cover models, and then in future lessons we'll hit properties, algorithms, and mental math. In fact, beginning Chapter 6 is really the beginning of a whole new section in our course. We're hitting the third part of the course, which is on operations. Part 3, Making Sense of Operations. For each of the 4 operations, addition, subtraction, multiplication, and division, we'll talk about models of that operation, we'll talk about properties, algorithms, we'll talk about some mental estimation, mental calculation. There's a lot of properties, models, algorithms. This section of the course is vocabulary heavy. So that's why I made these 2 pages at the beginning of your worksheets for the remainder of the course. As we go through the operations, refer back to this page again and fill it out as we go, just as a handy reference for keeping all of this terminology straight. Okay, so let's get back to addition. And today we're going to look at addition models. There are 3 models for addition: joining groups, joining measures, and moving along the number line. Joining groups. This is the simplest model of all. Basically, I have a group of objects, I have another group of the same object, I put them all together and I count the result. This is the most naive way of thinking about addition. This is what a child who first learns addition thinks about. Just joining objects together. I have 5 bears and 6 bears, put them all together, count them up, and we have 11 bears. So 5 plus 6 equals 11. The next model, a little more sophisticated than joining groups, is joining measures. Whereas groups means I have discrete objects that I'm counting up. With measures, it's a continuous quantity that I'm working with. For example, I might have a bar that's 6 inches long and a bar that's 12 inches long. And when I place them together, I get a new length that is 18. The 6 and the 12, those aren't actual objects that we're counting. I don't really have 6 of something that I can hold in my hand or 12 of something that I can hold and count. Lengths are continuous. You can imagine someone runs for 3 miles and then runs for 5 miles. How many miles do they run altogether? A popular manipulative for demonstrating joining measures are these Cuisenaire rods. So I could take a block of length 2 and then a block of length 3 and lay them over a block of length 5. And we see that they have exactly the same length together. And so there's our demonstration that 2 plus 3 equals 5. Cuisenaire rods are really nice also for demonstrating addition with decimal points. Maybe I could take this rod that has length of 10 centimeters and maybe we define that as being 1, as being our unit. Then I could demonstrate something like 1.2. I take that red rod of length 10 and I take, well, maybe it's an orange rod of length 2, put it together, and I have a length representation of 1.2. So in this way, the Cuisenaire rods help us abstract or generalize the idea of addition. In this way, maybe Cuisenaire rods are a little more powerful than simply joining groups. With joining measure, we have a new way of thinking about addition. Our third model is moving along the number line, and this is the most abstract of all. The number line itself is a fairly abstract idea. It's not like we see number lines in real life. But if I wanted to demonstrate 5 plus 4, I can imagine starting at 0, moving 5 to the right, and then moving 4 to the right, and seeing what number we end up at. We end up at 9, so 5 plus 4 is 9. One of the powerful things about the number line addition is that it also leads naturally to the idea of subtraction. What if I wanted 6 minus 2? Addition can be represented as movement to the right, and subtraction can be movement to the left. And so 6 minus 2 equals 4. The number line also leads us to think about things like negative numbers. So movement along the number line really is a powerful way to abstract our ability to add and subtract numbers. There are three common manipulatives that are used when demonstrating addition for little kids. The first of them we discussed was the Cuisenaire rods. This follows the joining lengths model of addition, and we can use the Cuisenaire rods to also understand addition of decimal numbers. Another is bundling sticks. Bundling sticks, we have these actual objects, these actual sticks, and we can bundle them together. We usually bundle them into groups of 10, and so this whole group altogether we can quickly read off as 10 plus 10 plus 5, or 25. In a classroom, people often use popsicle sticks. Bundling sticks follow the model of joining groups, because we really have groups of objects that we pull together. And you could demonstrate decimals also with bundling sticks. Maybe you could represent a 1, a unit, as a bundle of 10 sticks, and then each of these individual sticks would count as 0.1. A third manipulative people often use are red-yellow chips. They're just chips about the size of a quarter, red on one side and yellow on the other. And we can treat them like joining groups. If I say wanted to add 5, 1, 2, 3, 4, 5, and then the yellow might represent a negative. And so if I put 3 yellows in there, yellow, 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 the yellows might represent negative numbers. So whenever I have a group of a red, yellow, a red, yellow, a red, yellow, they go away. The plus 1 and the minus 1 cancel each other out, and I'm left with 2. So the red-yellow chips actually help us visualize addition with negative numbers, where the addition performed here is 5 plus negative 3. And this uses the joining groups model. All right, that's all I have to say for this lesson. Fill out the worksheet problems, give the homework problems a try, and let me know if you have any questions. Thanks.